The second podcast on nomenclature will cover compounds that have transition metals in them and also compounds that have polyatomic ions. So let's address the transition metals first. Transition metals are those elements found in the middle of the periodic table, and those elements generally have more than one possible charge. So when you name a compound containing a polyatomic ion, you must put a Roman numeral in the name to indicate which metal ion is actually in that compound. So for example, here you see copper plus 1, copper plus 2. Those two metals will form different compounds depending on their charge, and the same with iron plus 2 or iron plus 3. So in the name, we must include a Roman numeral to indicate which metal is actually in the compound. So for example, if we look at FeCl3 at the bottom there, Cl has a -1 charge, and there are 3 of them, so that's -3. To balance that charge then, the Fe must be the +3 version, so therefore that compound is iron, Roman numeral 3, chloride. Notice the second one, CuCl. Again, we know that chlorine has a -1 charge. So in order for that compound to have a total charge of 0, the copper must be +1. So we would call that copper, Roman numeral 1, chloride. Notice the tin fluoride there, the SnF4. Fluorine, we know from the periodic table, has a -1 charge, and there are 4 of them. So the total charge there is -4. So therefore the tin, to balance that charge, must be +4. So tin, Roman numeral 4, chloride. Now, there are some exceptions in the transition metals that do not have Roman numerals because they don't have multiple charges. And if you look at the blue there on the screen, you'll see silver, Ag, zinc, Zn, cadmium, Cd, and aluminum. Those 4 actually will not have Roman numerals because they're generally charged just singly. Silver +1, zinc and cadmium are both +2, and aluminum is +3. Now, these are some of the older names for the cations. So many years ago, instead of saying iron Roman numeral 3, we would say ferric. Instead of saying iron Roman numeral 2, we would say ferrous. And notice that the IC ending there for all of them, those are the metal ions that have the highest charge. And then notice that the OUS ending, those are the metal ions that have the lower of the 2 charges. We're going to stick with the systematic name, but I wanted you to be aware of this older system as well. Now, this is a learning check to see if you understand what we just discussed here in the podcast. So you may want to pause the podcast here, write the names for the 5, and then in the next slide you're going to see the solutions to all 5 of them. So I would pause now. Okay, solutions to those 5 that you just practiced. Notice that FeBr2, Br is a -1 charge, and there are 2 of them, so that's -2. So the Roman numeral on iron must be a 2. The second one, CuCl, if you look Cl up, its charge is normally -1. And notice that to balance that charge, the copper has to be a +1, so Roman numeral 1. SnO2, that's tin and oxygen. Notice that the oxygen from the periodic table has a -2 charge, and there are 2 oxygens, so that's a total of a -4 on the oxygen. So therefore tin has to be a total +4 to balance that charge out. And then Fe2O3, oxygen again is -2, and there are 3 of them, so that's a total -6. So then the total iron charge has to be +6, but there are 2 of them. So each iron has to be a Roman numeral 3. So iron, Roman numeral 3, oxide. Mercury is kind of a funky ion. It's a diatomic of sorts ion. So sulfur is -2 from the periodic table. So mercury must be +2. And then each one of those mercuries, since there are 2 of them, must be +1. But again, mercury is a little strange sometimes. That mercury 1 is actually a sort of diatomic mercury.